We physicists have waited 100 years since 1916 for this photograph.
For about 100 years, we've had this picture of black holes as the universe's ultimate dead end, right? This point of no return, where everything, even light itself, gets crushed into nothing. But what if that entire picture is just wrong? A revolutionary new discovery suggests that it is, and it's forcing us to rethink everything we thought we knew about these cosmic beasts. And look, we're not talking about some minor tweak in a physics textbook here. What we're diving into is a fundamental shift in how we see reality itself. And it all starts with one of the most important announcements in modern science. That's the voice of theoretical physicist Michio Kaku. And when he says that, he's not just talking about that famous first snapshot of a black hole. No, he's talking about what the data behind that image is telling us. It's the answer to a question we've been asking for a century, and it's an answer that nobody, and I mean nobody, saw coming. The tool that changed the game was the Event Horizon Telescope. And you gotta understand, this isn't just one telescope. It's a whole network of radio dishes all over the planet, all working together to create a virtual telescope the size of Earth. And the observations we finally got from this thing didn't just confirm our old theories, they pointed to a massive flaw in them. They challenged the one core idea we had, that the inside of a black hole is a place of total final destruction. Okay, so let's just do a quick recap of the old model, the one we all learned in school. You've got the event horizon, that's the point of no return. Once you cross that line, every path you could possibly take leads to one place, the center, a single point called the singularity, a spot of infinite density that grinds up matter, energy, and information into absolute nothingness. Or so we thought. This new evidence flips that entire idea on its head. We're now shifting from seeing black holes as these cosmic vacuum cleaners that just delete parts of the universe to seeing them as something way more profound, cosmic gateways. They're not places of destruction anymore, they're places of transformation, where the universe doesn't actually forget, it recycles. Now, to really get why this is such a mind-blowing shift, we have to talk about a problem that has been a ghost in the machine of physics for 50 years. It's called the black hole information paradox, and it's basically a civil war between the two biggest ideas in all of science. And this is the fight right here. Think of it like this. If you burn a book, is the information in that book, the words, the stories, is it truly gone forever? Quantum mechanics says absolutely not. The information is just scrambled. It's transformed into the arrangement of smoke and ash and heat. It's a fundamental law. Information can never be destroyed. But then you have Einstein's general relativity, which says a black hole's singularity does exactly that. It permanently erases information from the universe. So you see the problem. These two theories give us completely opposite answers. One of them has to be wrong. And then, back in 1974, Stephen Hawking came along and made the whole problem even worse. He proved that black holes don't live forever. They slowly, painstakingly evaporate over billions of years by leaking something we now call Hawking radiation. The trouble is, this radiation seemed to be totally random. It was just heat. It didn't carry any details about the stars or the planets or anything else the black hole ever swallowed. So, when the black hole finally evaporates and disappears completely, where did all that information go? That was the paradox, and it stumped the smartest people on the planet. For decades, this just seemed like an impossible problem to solve. But the answer, it turns out, was hiding in plain sight the whole time. It was tucked away in the mathematics of a very particular kind of black hole. Not just any black hole, but a spinning one. And this is the question that changes everything. Because when you think about it, almost everything in the universe spins. Planets spin, stars spin, entire galaxies spin. So it only makes sense that most black holes are spinning too. And when you add rotation into Einstein's equations, that central point of destruction, the singularity, it completely changes into something else. And this is the key. A mathematician named Roy Kerr figured this out way back in 1963. In a spinning black hole, matter doesn't get crushed down to a single point. No, it gets squeezed into a spinning ring, a ringularity. The best way to picture it is like a cosmic smoke ring. Just a one-dimensional loop spinning at an unbelievable speed with unimaginable density. Okay, and here's where it gets really, really weird. This ring has a hole in the middle, and the math showed that, in theory, you could pass right through that center without being crushed into oblivion. This wasn't just some tiny loophole. It suggested the ring itself was the entrance to a wormhole, a tunnel through space-time itself, a gateway to another place, maybe another time, maybe another universe entirely. For decades, this was just a mathematical curiosity. Now, it's the key to everything. So, how on earth do you make sense of a stable wormhole? And more importantly, how do you get rid of that information destroying singularity for good? Well, the answer seems to come from our most cutting edge and, let's be honest, strangest theory of reality we have string theory. It completely reimagines what the inside of a black hole is even made of. The basic idea behind string theory is that if you could zoom in to the most fundamental level of reality, you wouldn't find tiny little dots, like particles. You'd find tiny, vibrating loops of energy, strings. And each string vibrates at a different frequency, kind of like a violin string. One note gives you an electron, a different note gives you a photon, and so on. Every particle in the universe is just a different song played on these cosmic strings. So, when you apply this idea to a black hole, the singularity just vanishes. It gets replaced by what physicists call a fuzzball, a super dense, tangled, vibrating mess of all these fundamental strings. And just like that, poof, the information paradox is solved. The information that falls into the black hole isn't destroyed. It's just absorbed by this fuzzball. Its unique patterns get woven into the vibrations of all those strings. The black hole literally remembers everything it's ever eaten. Now, this leads us to one of the most brain-melting ideas in all of science. It's called the holographic principle. You know how a hologram works, right? You've got this flat, two-dimensional piece of film, but it contains all the information to project a full three-dimensional image. Well, this principle suggests that a black hole is kind of like that. All the incredibly complex 3D information of that fuzzball on the inside is perfectly encoded on the 2D surface of the event horizon on the outside. The inside and the outside aren't really separate. They might just be two different ways of looking at the exact same thing. So let's step back. If black holes aren't destroyers, and if they store information like a hologram, what does that actually mean for us, for the universe? Well, the implications they're absolutely staggering. First and foremost, it means the universe has a memory. The past isn't really gone. Every star that's died, every particle interaction, every piece of matter that ever fell into a black hole, it's all still there. Its information is perfectly preserved in a quantum archive. Just think about that for a second. Black holes aren't cosmic tombs. They're cosmic libraries. They are by far the most efficient information storage devices in the entire universe, holding the records of entire galaxies, stars, maybe even civilizations that existed long before we ever did. And this brings us right back to that spinning ring, to that wormhole. If a black hole doesn't actually lead to a dead end, then it has to lead somewhere. And this is where the fecund universe hypothesis comes in, the idea that black holes are basically cosmic seeds. The thinking behind this is surprisingly elegant. It turns out the mathematical conditions at the very beginning of our universe, the Big Bang, look uncannily similar to the conditions you'd find inside a black hole. So this raises an incredible question. Could our entire universe be what was created on the other side of a black hole that formed in some other parent universe? And if that's true, then the trillions of black holes in our own cosmos could each be giving birth to new universes right now, creating this vast, nested multiverse. And this, of course, leads us to the ultimate final question. If this theory holds up, could it be that we, right now, are living on the other side of an event horizon? Could our entire vast, expanding cosmos just be the interior of a black hole that exists in some much larger reality that we can never ever see? It's a thought that completely reframes our place in the cosmos. What we've always called the beginning of everything might just be one small event in an endless, beautiful cycle of cosmic birth.